All right, now we are getting into what is known as scientific notation. Scientific notation basically are numbers that they use, obviously, in science when they're talking about numbers that are really big or really small to help compare data or to do calculations, but normally you would not write them out because they're just too big or too small. So we use a form called scientific notation, which multiplies a number by a power of 10. All right, so scientific notation is written as a product of two factors, like a and 10, where n is an integer that's between 1 and 10. So basically, it cannot be under 1 and it cannot be a two-digit number. So it's always going to be, like here are the examples, 3.4, 5.43, 2.1. It can't be a two-digit number like 34.3. That would not be considered scientific notation. Or it can't be a decimal where that front part is 0, right? 0.53 can't be that. It would have to be a number between 1 and 10, but not a double digit. All right, so let's talk about the difference between standard form and scientific notation. So standard form I'm going to abbreviate as S, or standard form into scientific notation. You could see FF to SN. That's what SN stands for, scientific notation. All we have to do, if we are dealing with a big number and we want to go to scientific notation, we move the decimal point where the number is between 1 and 9. So one way you can think of it is for large numbers, we're going to have a positive exponent, and small numbers are going to have a negative exponent. And the exponent will be the number of places we move that decimal. We physically move it, right? So if I look at this number, again, big number, positive exponent, right? So 56,900,000. And I look at this number, and to make this number between 1 and 10, we put the decimal point there. Now, the decimal point in a whole number is always at the end of wherever it is if you don't see it, right? So we need to move this decimal point between there, and we can call this 5.69, and we can drop the rest of these zeros. We don't put those zeros in the final answer, because our goal is to make this number more manageable. All right, so now we have to put an exponent with this 10. The way we figure out what exponent, we literally count from this exponent to the exponent where we placed it. So 1, 2, 3, 4, 5, 6, 7. I moved that 7 spaces, so I put that to the exponent of 7. All right, so it's a matter of, again, we're going from a standard form number to scientific notation. So take a look at this. Now we have a small number. Small numbers, meaning they're decimals that are less than 1, are going to have a negative exponent. So if I look at this number, to make all this numbers, I look for my significant digits where I get to that 9 right there, and I put a dot there, because 9.85 is between 1 and 10. So I would write the 9.85 there, write the times 10. Now we have to figure out how many we went from here to here. 1, 2, 3. 3 spaces. So that would be -3 because it's a small number, but that 3 is how many spaces we moved it. All right? So here we go. Let's practice these. Pause and practice if you need to. First thing is to write down the decimal number that you're going to use. In here, it needs to be between that 2 and that 6. So I'm going to write down 2.67. Always times 10. And this is the only time we put that X for times. It's just the way scientific notation is written. How many spaces did we move? 1, 2, 3, 4, 5. So it's to the 5th power. All right, another big one. Big number, positive exponent. We have to make this between the 4 and the 6. So we're going to write 4.6205. And when I get to the zeros, I stop writing those down. I'm not going to write them, right? Just like I didn't write down those zeros. Times 10. And now how many spaces did we move it? 1, 2, 3, 4, 5, 6, 7 spaces. Times 10 to the 7th power. All right, now we are dealing with the small numbers, negative exponents. All right, so if I look at this, to make this number between 1 and 10, the decimal is going to go between that 3 and that 2. So I'm going to write down this number only for my scientific notation. Don't worry about those zeros. So 3.25 times 10. I'm going to have a negative exponent, but let's see how many spaces we go from here to there. 1, 2, 3, 4, 5. So negative 5. Over here, remember I've got to make this between 1 and 10, so my decimal is going to have to go here. So my main number is going to be 9 times 10. How many spaces? See, I like doing these little loops here because it helps me keep track, and then I can count in my head or count out loud, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. So the negative 9th power. So those are all written now in scientific notation. We have a number that's between 1 and 10, but not 10, less than 10. And we have the times 10 to an exponent. So that is going from standard to scientific notation. So what if we have to go from scientific notation to standard form? Well, you just reverse the process, right? And again, positive exponents mean big number. Negative means smaller number. So we start at where the decimal point is. And if you don't see a decimal point, then assume that it's right there, right? This one we can actually see the decimal point. This one will be just to the right of that number. All right, so if we have a positive exponent, we're moving it to the right, we're going to make it bigger. If we have a negative exponent, we're moving it to the left and making it smaller. And then the spaces that are unoccupied by numbers, we put zeros in there. So if I move 1.55, so if I have 1.55, I need to move this 6 spaces to the right. So 1, 2, 3, 4, 5, 6. Put a decimal point there. And these spaces I'm filling with zeros. So my number is 1, 5, 5, and then 1, 2, 3, 4 zeros. And then I'd start back from my decimal point. Every 3 I can put a comma. So you can see that that number, written in standard form, is 1,550,000. All right, with the 2, all right, now I need to go back 11 spaces for this. So I need some space. So I'm writing 2 here, my decimal's here, and I got to move 11 spaces. So there's 1 and then 10 more, right? 2, 3, 4, 5, 6, 7, 8, 9, 10. That's going to be 10 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9. Or is it 9? 10, 11. Did I go enough? I have to go 11, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I got to go 11, right? Because that's 11. So I should have 10 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There we go. So this number written in standard form is 0. That's where our decimal point is. 10 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 2. Really small number, which is why they like representing it in scientific notation. Can you imagine having to write this number out every time you were doing a calculation? Nope, this is where we want to be. All right, so let's practice moving them the other direction. So this one, 12. We got to move it 12 spaces to the right. So there's 1, and then how many more spaces? 11 more. So watch this. 3, 2, that was my 1. Now I need 11 more zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Pain in the butt. Comma every 3. Comma. That's a big number. What is that? Thousands, millions, billions, trillion, 3.2 trillion. Boom. Big number. All right, this one over here. We got to move it to the right 4 spaces from here. So think of it this way. 5.07, moving it 4. 1, 2, 3, 4. Fill those with zeros. Rewrite without the little lumpies in there. 0, 7, 0, 0, comma, every 3. 50,700. A couple negatives, moving it the other way, right? So we got to go this way. 4 spaces. 1, 2, 3, 4. Put a dot there. Fill those with zeros. We got those 3 zeros in there. Make sure you make those loops wide enough so you know how many zeros to put in there. So this would be 0.3056. This we only need to move -2, so 1, 2, that's a new decimal point, and we got the 0 there, 0.083. All right, that's pretty much scientific notation, going from standard form to scientific notation and scientific notation to standard form.